Okay, picking back up with our cross product lesson, we were dealing with this example where we had 3 points in a plane and they were points P, Q, and R. We found vector PQ, we found vector PR. We did a cross product and we worked that out at the end of the last video. We found that PQ cross PR was a vector. It was the vector 6i plus 6k. And just something I want to point out, vectors found by cross products are always, always, always perpendicular to the two vectors in the cross product. So we're guaranteed that what you just found is a vector that's perpendicular to the plane. We're asked to find a unit vector perpendicular to the plane though. And certainly we have 6i plus 6k. I guess what I'd like to point out to you is I'm looking at 6i plus 6k as a vector of 6, 0, 6. You might guess that this vector does not have a length of 1. Tell you what, how about we divide all these components by 6? And I could say that if we had that, we'd have the vector 1, 0, 1. Now, this is still a vector that's perpendicular to the plane. You look over here, I highlighted this yellow vector, the 6, 0, 6 vector. If I were to divide by 6, I'd still have an arrow that's perpendicular, but it would be 6 divided by that length, or that length divided by 6, I should have said, quite a bit shorter. Even right here, when I'm looking at this vector, and you know what, I'll just call it vector u, just to call it something. I could find the length of vector u. It's easier to find that. Pythagorean theorem would be 1 squared plus 0 squared plus 1 squared. And that, of course, would just be the length of radical 2. Now, why do I bring that up? This normal vector that I'm actually looking at, I want to divide by that. I want to take all my components in vector u and divide by its length. So I'd get 1 over root 2, 0, comma, 1 over root 2. This would be a normal vector, a vector with a length of 1. Now, by the way, we could have done that with our PQ cross PR vector. We could have found the length of that, and it would have been a bigger number. But when we divide and when we'd simplify, we'd wind up getting the exact same thing. Let's just wrap up with this very last example here. It says, with the same problem, find the area of the triangle with the vertices of P, Q, and R from the previous problem. Well, we know that the area of a parallelogram is the magnitude of PQ cross PR. And that would be the magnitude of 6, 0, 6. Now, we could do the Pythagorean theorem right here and say that's the square root of 6 squared plus 0 squared plus 6 squared. And, that's 36 plus 36. 2 36s, that's really 36 times 2. That would become 6 radical 2. And that's the area of your parallelogram. The area of a triangle that's formed there, of course, is going to be half of that parallelogram. So we'd get 1/2 of 6 times radical 2, leaving us with 3 root 2. So sorry I couldn't finish those last 2 problems up in our previous video, but hope all is going well. Try one more problem just to see how you're doing.